Hello, everybody. Good morning, good afternoon, good evening, wherever you are in the world. Thank you for joining us today. So there may be a few folks coming in as I begin this, but I'm just going to start off with a quick introduction to what today's session is going to be all about. So we're going to be exploring real-time virtual telescopes, transforming university learning. And it is a great honor to have with us today Professor Dr. Björn Poppe and Paul Cox. So Dr. Poppe is from the University of Oldenburg. Paul is our Chief Astronomical Officer here at Slooh. It's a real pleasure to have you gentlemen with us. My name's Glenn. I look after partnerships as Director of Partnerships for Slooh. So what is Slooh for anyone who's less familiar? It's a powerful way to bring real and live astronomy to K-12 schools and universities worldwide. You can see quite a number of the institutions that we're working with, and just a selection at the bottom of this slide here. But essentially, we're providing professional grade, remotely controlled mountaintop telescopes, along with a slew of, no pun intended, additional curriculum and activities and quests that Paul's going to be showing you in just a moment. 24-hour access worldwide to the best quality telescopes based in Canary Islands, Australia, and Chile. Students conduct real-time observations and research 24 hours a day. So no matter what time it is, they can be accessing the stars through Slooh. Fully curriculum aligned, making it perfect for assignments, labs and projects, large or online classes, and of course research as well. So both for undergrad and postgrad, as well as for K-12 schools, as I mentioned. And as you'll see here, and Paul's going to talk a bit more about, and I'm sure Bjorn will mention as well, gravity points. So students earn gravity points, which are rewards for completing quests and activities. And these, of course, increase and measure engagement and attainment. And we also provide teacher dashboards to be able to view those achievements. So with no further ado, I'm going to allow Paul to give a bit more of a deep dive into what that all means.
Thank you, Glenn, and welcome everybody. Before we talk to Professor Poppe, I'm going to take you on a real lightning tour of the platform, and it is going to be really quick because we've got some other videos that Glenn will share with you in an email afterwards where we take a deeper dive into the demo. But what we can see here is I'm logged in with my educator account, and we land on what is called the dashboard. We can see all the standard elements that we've got on the website. So we've got our telescopes, which we'll take a quick look at now. We are going to take a little look. I'm going to show you how a student would schedule an advanced mission a little bit later as well. But we've also launched our science platform as well. So students are now using satellites, Earth observation satellites, to peer back down to Earth. We've got our quest learning activities. I'll show you some examples of the output from that. We've got our community. Our workspaces are where you and your students have your own private area. It's also where you manage students as well. You can invite them onto the platform. You can assign quest learning activities, and you can monitor and track their progress as well. We've also got a whole series of guides about astronomical objects, concepts, and all manner of things. But I'll take you for a very quick tour down the dashboard, and then I'll just show you the telescopes very quickly. We can see here, actually, we've got some great opportunities at the moment. There's a competition running at the moment where one of your students can get an internship over summer to help us write more quest learning activities. But here we've got observations. Now, observations are images and data that students have captured and share with the rest of the community. And this is part of the gamification, because every time they do that, they earn these gravity points. Bjorn's going to talk more about that a little bit later, because it's a superb engagement tool for your students. That's what we're finding, and the most successful educators using Slooh are charging their students to earn gravity points and go up the league table. So these are observations that are shared, and there's actually a competition there as well that we're running. There we can see our workspaces. We'll take a very quick look at that before we finish. Here are the telescopes, so we can see the Chile telescope's currently online, the Canary 5 solar telescope is currently online, and Australia 1 is online. So that's we've timed this one perfectly to have all three observatories online. Missions. Missions are a 5 or 10 minute period of time where one user, one student has selected the target and a whole bunch of other parameters for that mission. But it's important, and we'll see this in a second, all students can watch the live feeds and snap images and grab data from all of the live missions. They can also join somebody else's mission as well. So we can see there we've got other missions, there are our quests, and then all of our photos as well. You can see here all of the images that you're going to see today were captured from the live telescope feeds. But we saw there that some of the telescopes are currently online. Sorry, having problems with my mouse. So we click the telescope icon, and actually, I was going to show you. We'll show you how to schedule a mission a little bit later. But let's just take a look to see what's online. Let's take a look at Australia 1 here. Excuse me. I had some audio commentary there coming over explaining this object. Now, this is a live view from the Australia 1 telescope. It's a half-meter telescope, research grade CCD camera on the back of it. And this is what your students can do. They can come in and they can snap an image of from any of the live feeds. We will just take a quick look. Actually, we've had some brilliant solar activity recently, and here we can see our live view from the Canary Islands Solar Telescope. And once again, your students, if they're doing a quest learning activity or you're teaching about solar activity, they can snap their live images, and all of these images are available for use in their quest learning activities. So we'll show you how to schedule the telescopes a little bit later, but I think we should get straight to the fireside chat with, actually, I will just show a couple of other things. I forgot to show you these. So the outcome from a lot of those observations are posters like these, and these are from university and advanced students. So here we can see a student's created a light curve from all the data that they've collected of an RR Lyra star. We can see some parallax measurements here, which is a great benefit of having two observatories, because you can actually do this with a near-Earth asteroid. This particular one was done with simultaneous observations from Chile and the Canary Islands. And they went on to actually measure the distance of these objects. So those are pretty cool, and that's one of our quest learning activities. We will show you that maybe in the Q&A at the end. But let's welcome Professor Björn Poppe. Björn, welcome. You are, I think, without doubt, our most successful educator using Slooh. Let's start off with the basics. How long has the University of Oldenburg been using Slooh?
Yeah, Paul, thanks for this nice introduction, also for the nice compliment. And also thanks for inviting me to this fireside chat. Actually, we are using Slooh since 2015 for our student training in astronomy, that some years before this whole learning environment was introduced here onto Slooh. And I have to say that we have now dedicated astronomy program here in Oldenburg, but the astronomy education is integrated into our physics and engineering courses. And within these courses, or within the whole university programs in Germany, there's something which we are called professionalization. And this is something like a general education option that every student has. So the idea is to encourage some interdisciplinary learning, some soft skills, and help the students to think a little bit outside the box. So they basically choose lectures from other areas. So in 2018, then we were asked to open our intro astronomy course for this program, so to allow also kind of cross-faculty participation. And of course, we had initially quite some large doubts, because this is really a mixed experience situation then, because we have students of all different levels to expect. But anyhow, we designed a course with a strong focus on skill-adapted learning, and especially on observation. So the students should learn astronomy, so to say. And of course, we thought that Slooh might be the ideal platform for this. And this really proved to be the truth. Since then, we had a really ever-increasing number of students. We started with 20, and during the last semesters, we have around 200, between 300 students. And this semester is the absolute record, where we have more than 350 students joining our lecture. So we really have problems finding a room, meanwhile, for the lecture. So yeah, but this is only possible because we have a really enthusiastic team here in Oldenburg. So we are usually 4 to 6 faculty instructors and a whole bunch of student tutors, which I really have to say thanks. So we're here at this point.
So what challenges were you facing at the University of Oldenburg before you discovered Slooh in 2018?
Yeah, the biggest challenge is, of course, for us, the huge difference in the students' knowledge, especially for this course. So because a lot of German students which are not studying physics have deselected physics in school as soon as it's possible. So initially they don't like it, so to say. They really are a little bit afraid of it, I would have to say. So we have there a mixture of people. One are barely even able to understand any kind of gravity law, while others already have heard quantum mechanics or even general relativity. So this was a big problem then for us, because we want to keep all these students, of course, interested and engaged. And they all should have the chance to learn something about our beautiful universe, like this. So, and then the next challenge was that we have so many students, so you have to grade them. And if you have such a big difference in the skills, you cannot just write an easy exam or an exam, because this is just not possible. And there, in particularly, we found good solutions in Slooh, because of course the easy programming of the telescopes is the thing that is really interesting for the students. But the learning environment, especially with the gravity points that they can earn, this was for us really a help, because this could help us to grade the students quite easily, I have to say.
I think so many students have that fear of physics and math, but when they see how easy it is to acquire their own data with mountaintop telescopes around the world, it gives a level of engagement which can start to eliminate some of those fears. But how do you use Slooh then in your introductory to astronomy lectures?
So we have, it's a kind of classical lecture. We have 2-hour lecture per week and then 2-hour seminar. And this all runs over 2 semesters. So at the end, they have like 8 hours per week astronomy. And we follow more or less a classical astronomy curriculum, starting in the solar system, then going out into the Milky Way galaxies, whatever. And but we have somehow divided the lectures in the kind of outreach level, where it's more than for the non-physics students. And then we also always have a part where we derive some basic physical laws as for our introductory lecture necessary. But right from the beginning, we tell the students that it's not really important for them to follow this equations if they're not able to do this. So they're invited, but it's absolutely fine if they don't do it. And then in the seminars, we have, of course, Q&A sections. We do hands-on learning, especially Slooh, or also some kind of other programs. We show them how to do astrophotographies, how to do photometry, exoplanet transit. So all these at least basic techniques. We show them how they might be used. Of course, they're not really trained to it. That comes later, but at least to get in first touch with this. And to get the grade, the students use the Slooh accounts or their Slooh accounts. In fact, they just get a part of the grade. So 2/3 of the grade can be earned with Slooh, so to say. And of these 2/3, 1 grade is just earned by getting gravity points. So they can just do what they like. They can take quizzes, they can submit observations, they can discuss, and they have to pass or get at least 1,500 gravity points. And if they get 3,000, then they get an A, so to say. But many students just continue earning gravity points once they're used to the systems, because they are really excited in using this. And last year, that was really astonishing. Our students reached the first time more than 1 million gravity points, which was really a good, I mean, it's just a small success, but it's kind of magical number for us, so to say. And then they use also the Slooh data to create a, let's say, quasi-scientific poster, because they use the Slooh data to create a nice astrophotograph of one object, and they should describe this object then on the poster, and then we make a big poster sessions with all the participants and play then a little bit, a small conference, so to say.
Okay. We've used the word engagement quite a few times already in this, but how do you drive student engagement on the platform at University of Oldenburg?
Yeah, that's maybe quite astonishing. We don't do too much, actually. I mean, we let them run, we give them the introduction, and we also don't say do this and that quest, which has some relation to our lecture. We just say, do whatever you like, what you ever wanted to learn. And of course, we help them a little bit. And we really have the opinion that Slooh is a supportive and well-prepared learning environment already on its own for each student. So it's quite easy to find something that they can do on their level. So they can take pictures, exchange ideas, they take the quizzes, and the most important thing is they can take the quizzes on the level they like to do and they are able to do. So if we, for example, have students who get rid of physics as early as possible and they choose for the beginning in elementary school quiz, why not? So it's probably for them exactly the right one. And our physics students really often then go directly to the college level quests. And all this activity is, so to say, rewarded with gravity points on a comparable level. So this really is a customized training, in our opinion, that makes it quite easy. And this really helps the student also to keep them engaged. And of course, we have this workspace that you just described. And in this workspace, we also have a tutor who is talking to the students all the time, who tries to support them a bit and to encourage them to also publish the observations then on the whole Slooh platform. So in this step, we try to bring them into a kind of discussion, because in our opinion, it's like with most of the cool stuff, if you can share it with other people, it's even more interesting. And we made quite good experience with this, let's say, easy and light way of engaging them.
It's interesting that you said some of your students choose to do elementary and maybe some of the school quests. It's important to point out because we find this quite a lot with different organizations from schools up to universities that students using the platform have access to all of the telescopes, but also all of the quest learning activities, no matter what grade. And we do find you normally have a couple of students who are really taken to the platform, and they can actually land up getting quite disruptive if they run out of things to do, but they never hit a ceiling. And that's one of the things I love to see certain students as they progress and rather enthusiastic. But where else are you currently using Slooh? Are you using it in other courses or activities?
Yeah. Actually, that was our initial thing with Slooh, to use it at other activities. We follow here, probably like most of the universities, a kind of step-by-step approach to help our students to develop the skills and the techniques of observations. So after the introductory lecture, at least the students who stay in our group, they then take more advanced things, like we have special labs on astrometry or photometry that they can just take within their master or within their programs, mostly bachelor. And then at the end, we usually end the education at the telescopes with a 1-week trip to a partner observatory in France, so where they can really use then 1-meter science-grade telescopes. And for this visit, they also have to prepare some measurements, and they have to prepare and suggest some first observations. And Slooh is also a perfect thing to prepare the things there. So to test things out, to see whether what you have thought about can be realized, so to say. And then we have one other example where we use Slooh for the education of our students. We, here in Oldenburg, one of our main subjects of specialization or interest is space environment. So that means something like safety of space missions, I would say. And we have a long collaboration with ESA in this part. And we do some radiation research, meteor research, but also debris and especially also NEO observations. And we have, over the last years, we have developed a complete robotic system for NEO observation. So the system downloads the interesting objects from the NEOCC homepage or from MPC or whatever and recalculates everything and basically does mostly everything automatically. And so during the last years, we've made several hundred observations and have been involved in the discovery of many, many NEOs. But for the students, this is too much because it's kind of a black box. And that's especially where Slooh comes into play, because the students have the options there to take these advanced measurements or these advanced observations, and that they really have to prepare the observations with data from the NEOCC or MPC. So they have to choose objects, they have to derive positions, they have to program the telescopes, and then they can do the evaluation later on. So this really prepares them to use our telescopes. And maybe another example, we also do sometimes observations for the AVSO, because this is also quite interesting for the students. So for those who do not know this, this is the American Association of Variable Star Observers. So they collect, so to say, data of variable stars. And some weeks ago, there was a kind of kind of program where they ask people to take pictures of V1159 Orionis, so that's a cataclysmic variable. And we just try to do this also with Slooh, because this is quite nice that you have a 24-hour coverage of the night sky, of course. And maybe, Paul, you can show here a little bit more about how this advanced missions are booked, because this, of course, needs to be done for questions like this.
Yeah, and this is an interesting example as well, because it's actually quite low down on the horizon. It's only visible at the beginning of the night. So I've just hit the telescope icon and schedule mission. So we're going to show you how to set up an advanced mission here, an advanced photometric mission. So we'll hop over to by telescope. I think let's try Chile 2, the Chile 2 telescope, because it's well positioned there. We'll hop over maybe that's tonight. Hop over to Wednesday and we'll grab an early slot. So we've got an early slot here. We select that particular mission. So far we've selected the telescope, we've selected the date and time. You can see here there's a variety of ways that you can schedule the telescope. There's some really simple ways using just a 3-step process. You can go by catalog. We've got 14, I think, astronomical catalogs in here. But this is the one that we need for this particular mission. It's by coordinates. And it's a few steps that we enter here. So first of all, we're going to set the object type. Well, it's a star. We are going to enter some coordinates. So excuse me, I'm just going to do some cutting and pasting because I pre-prepared these. So let's get that in there. And we'll stick a name in because the name is going to help other members, because I'm going to show you how this helps other members in a second. So there's our name. And we're going to check the object visibility first of all. Good news, the object is visible. And here in step 5, you can see choose the image processing option. Now, this affects both the real-time processing, but also the data which is gathered. And if we scroll down this list, we can see we've got multiple luminance only. But here are some of our photometric processing options. We know that 45-second is pretty good for this. And we'll preview that mission and schedule it. So it's just confirming everything about this mission, schedule mission. We can go back to the schedule, and there you can see it's scheduled for us. Now, the student can watch this mission live, and any student can watch it live and snap images from it, but all of the data, including the FITS data, is going to be automatically saved for them immediately for use for processing in external tools or in our Quest learning activities. But I did just want to show you here that I noticed somebody else has also scheduled a mission here. So let's say I want to gather more data. There's 3 little buttons here. And if I click on that, I can say, join this mission. Now, what we've done there is all of the data from that mission too is going to be available for me immediately after that mission runs. So that is how to schedule a mission, an advanced mission, photometric mission using Slooh. We are also introducing spectroscopy later this year as well. So that's going to be quite good fun. Bjorn, will you use our spectroscopy capability later this year? Yeah.
No, we'll try it, of course. I mean, we also train our students in spectroscopy, and we do this in Oldenburg at the moment, of course, with our telescopes. But if you offer such an option, of course, we'll try to do it, because obviously the problem in northern Germany is that we do not have such a nice weather than Chile or the Canary Islands or even Australia. So we can do a lot of technical things here and train the students to program telescopes and to set them up and so on and so on. But if you really want to do observations, you really have to wait sometimes very long until the weather. Yeah, and this is really so the technique is decoupled from the observation a bit, and for this also Slooh is wonderful. And I mean, maybe you know this old proverb that the most valuable or best telescope is the one that you're regularly using. But I have to say, in this sense, Slooh is really our best telescope at the moment, because we get so much data out of it, right? Yeah,
and all of your students can be using the telescopes at the same time as well. Now we were delighted that the University of Oldenburg just signed up to use Slooh for the next 5 years. So we're looking ahead to that. But this has opened up new partnership opportunities. Can you tell us about those maybe?
Yeah, that's really a fascinating development for us, and we are really looking forward for this cooperation. So what we think is that we hope to really develop more advanced lab projects for the education of the students, which might be then also available, of course, for other universities as well. So personally, I have to say one of my favorite projects would be to be involved in a group of university teachers who develop such a core curriculum of advanced astronomy using Slooh, because I think this is definitely possible, and maybe it has more potential for university education than it's used so far. So our goal would be to be helping here a little bit, I have to say. On a national level, I hope that we can support Slooh's mission a little bit to offer an easy and accessible and fascinating view of our universe, especially also for students, especially also for pupils from school, because we have already started, so to say, on a regional level to form groups for students from school who might then, so to say, join the university a little bit earlier on to get into contact with us, and hopefully afterwards they then can also enter our program, so to say, at the university. So it's a little bit outreach and connecting the students to us. And what's really fascinating is that two of our students will probably join you on a trip to Tenerife later this year, or in some months, to do some maintenance and to do some construction stuff at the observatories. That's also quite interesting, I have to say. So I think there are really many options, and I can just reply and say that hopefully there will be even many more years of our collaboration.
I mean, the opportunities are absolutely boundless with this, but I'm especially looking forward to sharing a maintenance trip to the Canary Islands Observatory with two of your students, especially because we're going to be moving the half-meter telescope, so that's definitely a three-person job. So, we'll wind up before we go to Q&A. Can you give us a little bit of a summary? What has the impact been to your faculty, and how has Slooh made teaching more seamless for you?
Yeah, I mean, the biggest impact, I have to say, for our faculty, I mean, for our group, Slooh, as I said, is, so to say, a very important tool to support the education of the students in our group, to bring them, I have to say, faster towards real astronomy. And it's also with our PhD students or whatever, if they find something which might be interesting to have a look at, they take Slooh. That's the first step they always use, so to say. So it's also for the everyday work in our group, it's a quite important tool. But for the faculty, the thing is that Slooh really offers offers the option to engage and to interest a lot of students from many different faculties, or from all different faculties, to astronomical questions, and therefore also a little bit more to physics. And that's really a big benefit also, of course, for the faculty then at the end.
Wonderful. Thank you very much, Professor Poppe. It's been a fascinating insight to how you're using Slooh's Space and Earth Science platform at the University of Oldenburg. We'll hand back to Glenn for Q&A. Just as we are watching, I just wanted to share this. This is a live view from the Australia half-meter telescope, and the Orion Nebula has just gone into full color, and I've just snapped my own image of that. Back to you, Glenn.
Thank you so much for that, Paul. Appreciate it. Okay, well, we've had some questions, but please do keep the questions coming in. You feel free to use the Q&A section or the chat section for that. We're going to keep going past the half hour, maybe for another 15 minutes, because we've got a few questions that have come in. So let's kick off with one that I think would be a great question for Professor Poppe. So how do students use Slooh during class time? So we understand that, they can schedule times to use the telescope at all times of day and night. But how are they using it in class time?
Actually, I hope in class time they don't use the things, because there I give the lectures. But yes, of course we do have some special sessions, these seminars where we explain them how to use Slooh, and if they have problems, we help them out, of course. And from what I've heard, most of the Slooh students are using Slooh in, let's say, short breaks during the day, so they can just take it with a smartphone, they can program it with their iPads or with their tablets. So they basically use Slooh wherever they like to, maybe even other lectures if they are too boring, but hopefully not in mine, I have to say, of course.
Fantastic. And for schools that that do want to use it within class time, Paul. How have we experienced some of our Slooh teachers using it within class time?
Well, they do tend to assign Quest learning activities. So I didn't actually show you that at the beginning, but if we hop over very quickly to the Quest tab, we can go to all Quests here, and we have you can filter by subject level, by learning progressions. So what we find is, especially at school level, not necessarily at college level, is teachers don't know the order of quests. So we've got what are called learning progressions, and this presents a series of quests which basically progress their students through. This is the college learning progression. So we start off with something simple with a beginner quest, and then we go through more advanced. We've got Kepler's planetary motions. We've got the discovery of Pluto, where students take images of Pluto over several nights, animate it within the Quest animation tool, and that's the primary use. But they do focus a lot of effort in their workspace. So we did mention those right at the beginning, and this is an educator's workspace, so it's a private area for the students and the teacher. We can see here Quest assignments. So Björn was saying they don't assign quests, they give their students free rein, and that's what a lot of universities do. The students are sharing observations, and this is key because it teaches scientific collaboration. It's about the gamification of the system. And here we can see, the students are sharing their observations with the rest of the community. But also we've got our own discussion group as well. So the students, a lot of educators here are discussing quests, giving instruction to their students. The students are posting some of their best work and things like that. But we've also, by the way, this is, I'll show you very quickly, this is the management tool really for all educators, where they can invite students, they can check progress, they can see how many quests they've done and things like that. But then lastly, we've talked about the gamification of the platform quite a lot. And Björn has shown this at the University of Oldenburg, that the gamification of this platform is just as appropriate at university level as it is for school use. And it's really surprising just how competitive both individual students, and we can see our top student at the moment is Lars from University of Oldenburg. And it is remarkable to see just how competitive the students get. So it is a huge part of the platform, and everything that they do on the platform earns them those gravity points.
That's fantastic. And Kaushik's actually asked a question that's quite similar, which was, are there any sample activities and lesson plans available that we can go through? Now, I think you've gone through an activity there, but I wonder, Paul, if you could just speak very briefly on lesson plans and curriculum and how that works within Slooh.
Yeah, so Björn and I were talking about this actually at length just before the webinar, because when it comes to different astronomy curricula across the world, they are quite different, but they're obviously, because astronomy is a topic, there are these core elements within it. We find that those are the same across all curricula. This is a good example, actually, of that. Most astronomy curricula deal in one way or another with the life cycle, the life and death of stars. And in this particular example, in this particular quest, students are capturing images of stars of different solar masses, but they're then following the life cycle of those. So the supermassive stars, they then capture an image of something like the Crab Nebula when it ends its life in a cataclysmic explosion. But then planetary nebula, which is the end of our star. So what we find, Björn, I think you were saying that you were agreeing with this premise that there are these core topics across all curricula because astronomy is fairly ring-fenced.
Yeah, I absolutely agree. I mean, of course, let's say the level on which the students are learning this may differ a little bit. It depends, of course, on the let's say the age of the student or where it is inside the bachelor master's program, even later. But basically, these are all the same topics, I have to say. I mean,
Yeah.
at least from my experience.
So Kepler's laws and things like that. It's also important to point out that this particular example is an advanced quest, but we also have, so most of these core topics in the curricula, Glenn, are we have a quest at different grade levels. And that can be important, as Bjorn pointed out earlier, that some universities, if it's an intro to an astronomy course, maybe those students don't want to do the university life and death of stars quest. Maybe they want to do the high school or even the middle school quest because it's more of an introduction to the subject. I hope that answers the question.
Brilliant. Thanks so much for that. Another question here that we've got with regards to sort of non-astronomy students that are not studying astronomy specifically. If an institution or if an educator in this case is interested in opening up Slooh to more than just the astronomy students, what have been the key benefits for the students who are not astronomy students that have gained from Slooh? So I think this individual is kind of looking at maybe, proposing this to their leadership of, of expanding Slooh across to other departments, other students. What have been the key benefits for those other students that you've seen, Bjorn, at your university?
I mean, I have to say astronomy, or many people are interested in astronomy, and many people are somehow blown away by these beautiful images that are shown meanwhile everywhere. And of course, if you look through a regular telescope, you won't see anything of these. But anyhow, and a lot of students think, okay, this can just be done with really huge and expensive and maybe even space-based telescopes. And if then they come to us, use Slooh and take images which even have not the highest quality, but at least have some quality which they never have expected to get, then they are really, they're really happy sometimes. They really write emails. So this was the best lecture in my life, and that's the best topic I always thought about, knowing more about astronomy. I think the acceptance of astronomy and maybe even of physics in our area becomes much higher by using Slooh, because you can show that physics and even astronomy is not just for, let's say, nerdy people or nerdy physicists, but is for everyone available.
Yeah, that's right. And I think in terms of the equipment side of things, you mentioned there the access to the kind of equipment that we've got there that they might not have been expecting. We had a question in earlier on that said that essentially you said the students use research grade telescopes, but can you tell me more about the equipment and the observatories themselves?
Absolutely. I mean, they're world-class observatory sites. First of all, the Canary Islands, our flagship observatory at the Institute of Astrophysics of the Canary Islands. You ask a lot of people in the world, even astronomers, where's the largest optical telescope in the world? Well, it's the Canary Islands. It's not Hawaii. It's not a lot of the other places that they come up with, the Atacama and Chile and things like that. So first of all, we've got absolutely epic observatory sites. So Australia, we're literally a stone's throw. It's about half a mile away from the Siding Spring Observatory. Canary Islands, 8,000 feet, 2,000 meters altitude. The telescopes there, when I'm talking to a lot of educators, I tell them the telescopes that their students are controlling on these mountaintops, a lot of the students could fit inside some of the telescopes. Our half-meter telescopes are absolutely massive. In fact, Bjorn's students who are coming to help me with the maintenance visit, they will see that we will be climbing inside virtually to give those a good old clean. But students are also using this kind of technology as well. You can see it on my screen share, hopefully, if I'm appearing. This is a research grade CCD camera. The sensor in this is cooled down to minus 40 degrees C. And this is what gives us this absolutely wonderful quality data. There's all sorts of filter wheels and stuff like that go on the front of that. But we've also got the dedicated telescopes as well, like the solar telescope, which is a highly specialized solar telescope that students can use to study the sun. And we've got lots more developments coming this year. But frankly, I meet a lot of professional astronomers at the observatories during my visits there, and I take them for a little tour of Slooh's facility, and frankly, they cannot believe the technology and equipment that we are putting in the hands of students. So I think that's testament, because you see quite a lot of jaws open when they see what we've got.
Thanks so much, Prof. And the final question I think we'll address for today, a couple of people have asked in terms of is Slooh pay to view? The answer is no. I know that there are a few platforms of that nature out there, and indeed Slooh, people may be aware of Slooh for being like that. That's not been the case for a long time. It's a subscription as a service model, typically for a year. So you get full access to all of these wonderful things that Bjorn and Paul have been showing you today, talking about today. You'll have full access. There are different subscription levels depending purely on the needs of you and your students. But all of those wonderful quests and activities that you've seen Paul show you earlier are available to absolutely everyone. So any student from any grade level can use them. Paul, I wonder if you can talk a bit about our experience of how students are using those activities. And specifically, I remember you mentioning to me before about how some students, even at high school, might even be using university level quests during their days on Slooh.
Well, actually, we've got an absolutely classic example of that. If people go to www.slooh.com, if you hop down to case studies, we had a student who was at high school, and I started seeing the missions that she was scheduling, and I thought, oh, these are rather interesting. Well, a year later, we find out that this student, through self-directed study, has been studying RR Lyrae variable stars, and she lands up writing a scientific paper, getting that published. And last year, 2 years ago, got into MIT, and last summer had an internship at the Jet Propulsion Laboratory, where she was working on the Europa Clipper mission. Now, we can't take full credit for that, but I think Bjorn has hinted at this as well. Students, when they come onto the platform, go above and beyond, and that's what shows the level of engagement of the self-directed learning. They fly with it. They do way more than they're expected to, or have been asked to, or tasked by their educator to do. And what we see as they come into the subject, there are so many elements of astronomy, and that's what we love about it. A student can come in to start an intro to astronomy course and suddenly see an observation from another student and think, oh, I want to capture and monitor near-Earth asteroids. I want to learn more about that. And it sets them off on these different paths of study, potentially, in the case that we've seen and a whole number of other cases, on career paths as well. And my goodness, what opportunities this current generation have got to enter the space economy. There are such diverse careers available. It's not just about rocket science or astronomy. There's a whole gamut of career opportunities in engineering leading from STEM. And astronomy is just such a wonderful gateway science into so many of those different avenues.
Thanks so much, Paul. Well, I think we are pretty much on time. If you have any questions, please do reach out to either myself or my colleague Jimmy, also on the call, and you'll see our contact information. There we go, very nicely up on the screen right now. We've got email address, also WhatsApp. Do feel free to go to the Slooh website. As Paul mentioned, there's a lot of resources on there, case studies, some of those quests that you can try yourself. So have a little play there. But reach out, any questions, or if you want any more information. As Paul mentioned, I'll be sharing some content from other sessions with you as well for a bit more deep dive on the platform. Thank you so much, Dr. Poppe and Paul, for today, for the wonderful conversation and for your time, gentlemen. Greatly appreciated. And thank you so much, everyone, for joining today. Thank you.